Look, a very good morning to you all, and you're welcome to today's Signpost webinar. My name is Mark Gibson. I'm manager of the Teagasc Connected program. I hope you're keeping safe and well wherever you are joining us from today. Today, we continue to look at water quality, but from a slightly different perspective. Today, we're going to be looking at the role of pesticides in water quality and how they behave within the landscape. So to speak about this, I'm delighted to be joined by Professor Phil Jordan from University of Ulster. Good morning, Phil. How are you today?
Very well, thank you.
Great, great. And we're also joined by Pat Murphy, who's head of the Teagasc Environment Knowledge Transfer Programme. Pat, good morning to you.
Good morning. Good morning.
So, Phil, before we start your presentation, maybe you could just give us a little bit of background to the work that you're doing. And you're very familiar with the work we're doing on the agricultural catchments program as well. Of course, you spent some time working on that program. But yeah, just if you could give us an overview of your.
Sure. Yeah. As you said, I was working for a time with Teagasc on the agricultural catchments program, and my area of expertise is really on the dynamics and fate of nutrients in catchments, and more about trying to keep nutrients on the land and less being transferred to water. And I guess this new project, funded by the European Union through the Interreg program, is about water quality in general, but the role of colour, sediment, and also pesticides in our drinking water supplies, or trying to avoid excessive treatment of our source water. So I'm working with multiple partners, which I can introduce at the beginning of the presentation.
Very good, great. Okay, well, look, if I could ask you to share your screen with us, and we'll get on with the presentation. And just remind everybody that you can send your questions to us using the Q&A tab at the bottom of your screen, and we'd be happy to put those questions to Phil at the end of his presentation. So we'll hand over to Phil. Yes, your screen is coming up there.
Is that me? Is that shared?
Yes, we can see your screen.
Okay, I'll make a start. So the title of this short presentation is about MCPA herbicide. They're new insights, so this is new data, and this is catchment scale research, specifically in the northwest. So that's County Donegal and Tyrone. And I just want to say that I'm presenting this morning, but really a lot of the data analysis, data collection for this project is undertaken by others, specifically Rachel Cassidy, Phoebe Morton at AFBI, Kevin Aitchison, who's a PhD researcher at Ulster, and chemists down at AFBI as well, Stuart Floyd and Colin McRoberts. Myself and Donica are our institution lead partners in this particular project, Source to Tap. And Source to Tap is funded by Interreg, and there's a disclaimer at the bottom there from the European Commission. But on the next slide, just logos from the wider project partners. This is a very large-scale project, cross-border project, taking place mostly in the Derg catchment in the northwest, but also in the Erne catchment as well. Now, the high-level purpose of Source to Tap is thinking about source water or raw water, and how that is turned into drinking water. There's a website there to have a look at, and there's also at the bottom a video that you can look at as well. You can get the link from the PDF of these slides. And the high-level issues that might be impacting our source water as it's turned into drinking water in these areas are things like colour from peat, sediment from erosion, and also pesticides. And the purpose of Source to Tap really is to understand these things, but also to demonstrate mitigation and to provide an education package as well. And today, really what I'm going to concentrate on, as the title suggests, is the pesticide element here. That's the herbicide MCPA, and how we can add to the understanding of that pesticide as it moves from land to water. So MCPA is a herbicide, 2-methyl-4 Chlorophenoxyacetic acid, that's a very long word at this time of day, and I'm not going to say it again. It's a selective herbicide. It's used to control rush on grasslands and other broadleaf weeds. It's used for the establishment and maintenance of improved grassland. And it's applied by broadcast spraying. It's selective in that it just kills the things that the farmers want to be rid of, so it doesn't affect the grass. The problem is that MCPA herbicide, once it's been applied and it's doing its job, it's also highly mobile. It moves from the soil to water after rainfall. And trends in source water or raw water in both Northern Ireland and Republic of Ireland show that over several years, either the mean raw water concentration has increased or the number of raw water failures has increased over time. And you can see here, these data are between 2004 and 2016, and generally there's a trend of either an increasing raw water concentration of MCPA or an increase in the number of failures of MCPA in raw water. Now this is important because MCPA accounts for the majority of pesticide exceedances in source water supplies. So of all the pesticides that we might find in our source waters, MCPA accounts for most of it. And I think the most recent data I saw online was for over 60% of all pesticides was MCPA as found in our source water. And this is a focus of much research across the island of Ireland. Source to Tap is one project that looks not exclusively at MCPA, but includes MCPA in its project remit. But there are lots of other projects as well, mostly European Union funded, and I'm sure I've missed some out here. But two of these are funded by Interreg, and two by Horizon 2020. And the PestMan project, I think, is the most recent one, with Teagasc, NUIG, and University College Cork. So what's the problem? Well, in treated drinking water, well, the water that comes out of our taps, the regulated standards are for tiny amounts. We don't want any of this stuff in our drinking water really at all. And the maximum thresholds that are regulated for a single pesticide is 0.1 micrograms per litre. So it's a very tiny amount. And for the sum of all pesticides, 0.5 micrograms per litre. Now, I just want to put that into perspective because it's difficult to get your head around these tiny amounts. A microgram per litre is a microgram is a billionth of a gram. And what that means is that if we took a container of MCPA and just took 2 drops out of that, 2 raindrop-sized drops, and diluted that down into an Olympic-sized swimming pool, that would reach the threshold for a single pesticide. That's 0.1 micrograms per litre. So that's about 0.03 grams of MCPA salt into 2,500,000 litres of water. So that's why this is an issue. Now, source water, most of our source water across Ireland comes from surface waters, that's rivers and lakes. About 60 to 70% across Ireland, and around 40% across the EU. So surface waters are important source water supplies. And there is a complex process of treatment of raw water into drinking water. And here's the River Derg as an example in the northwest, supplying water to Strabane. Now this is a complex process. It's like a big chemistry set that clarifies the water and finally takes out the pesticides through carbon filtering and storage, and then onto distribution. And they do a great job at maintaining these standards and distributing clean water into our homes. Now, what do we know about MCPA? We know that it doesn't hang around in the soil. It degrades in sunlight and oxygen-rich environments. It's got something called a high groundwater ubiquity score, and you can Google those terms. It just means that it leaches to groundwater if the soil and the geology enable it to. It's also susceptible to surface runoff once applied and it rains. These are called incidental losses. So if there's an application and a rainfall following the application, then there's an incidental loss. So I guess as a scientist, we want to know what we don't know about MCPA. What are the things we don't know about MCPA? And we do this through review. We look at all the parts of the process from land to water where MCPA can be found, and we do a critical review. And this has been done already, and I've given a web link there with full access, open access to this review of the pesticide. And I might have to also mention Chagask staff here, Chris Fennell and Owen Fenton and Perrett Melander, who helped us with this review as part of the Water Protect project. And there's also a science bulletin, a shortened version of this, with a website there to have a look at. Now, the framework for the review is just based on a pollution transfer continuum, so source, mobilization, pathways, delivery, and impact. So that's the route that MCPA and other pollutants might take from the land to water and where an impact might occur. And the things we found that we didn't know were things like whether we can have alternative uses of MCPA. This is the research that we said was required, identifying knowledge gaps. The land use controls, how MCPA is mobilized, how MCPA persists in different water pathways, whether that's a surface pathway where water runs across the surface of the ground laterally, or whether it leaches down into deeper groundwater. And delivery, you know, we looked at the way that data is collected from MCPA in rivers and questioned whether a high resolution data would help with risk assessments. Now, the impact, we looked specifically at toxicology and ecotoxicology, and these things called synergistic effects. And there's a lot of research coming out from various parts of the world that suggests that pesticides in particular might, their toxicity might be increased if they're combined with other pollutants. So their toxicity becomes greater than the sum of their parts. So that's something to keep an eye on in terms of research for the future. Now I'm going to take you to a map and take you through the map very carefully here on the study area that's part of this work. And in the inset map in the bottom right, you can see that in the grey areas, the Derg river catchment, about 384 square kilometres, and that runs into the Stroul and into the Foyle system and into the North Atlantic. We also study at the same time a catchment just to the north, that's the Finn catchment, to get an indication of well, just to duplicate the effort in data capture. Now, the Derg catchment, to take you to the larger map here, the river flows from west to east, so left to right on the screen there. There's a downstream exit to Castle Derg, sorry, to the Stroul. It rises in the Blue Stack Mountains at this end of the catchment in two major tributaries, one starting in Loch Mawn, which itself is a source water supply for Ballybofey and Stranraer, and the tributary Mournbeg in the north here, round down to this D8 point, and another tributary from Loch Derg in the south, running in this direction to D7, where there's a confluence of the two major tributaries, and on it goes through Castle Derg and beyond. Now, also on this map are these purple dots. We've labelled them from LM, D1, all the way down to D10. And these were spatial sampling points where we started to question this idea of land use control. So studying specifically the mobilisation part of that continuum where we identified a knowledge gap. So each sample point was visited weekly between March and June 1 year. So the start of the spraying season into the spraying season. And we took a water sample from each point, and the analysis is very complicated, liquid chromatography analysis down in Affby, and that was done on a weekly basis. And then we looked at all the data for each location after we'd quality controlled and managed all the data. Now, just to take you back to this map here, I just want to orientate you on this map to D8 and D7, and also this area here to the left, the Blue Stack Mountain higher elevation. So the next photographs show typical kind of rough grazing area in the upper reaches of the catchment, and it's also forested. And then when we come down to the main picture here, you can see right in the background the Blue Stack Mountains on the horizon to the west, and then two tributaries, the Mornbeg coming down this direction to the confluence, and the Derg coming down this direction to the confluence, and the Derg River carrying on. And just to orientate you again, the two sample points there are the two major bridges crossing those tributaries, and these were visited weekly along with the other sample points. Now, this is a complex set of data, and just to take you through that, on the x-axis are the sample points that were on the previous maps. So LM at Lochmorn all the way down to D10, just east of Castle Derg. So generally going from upstream to downstream. And on the y-axis is MCPA concentration. And these numbers go up in an order of magnitude of, so they're multiplied by 10 each time, just so we can see the data on one chart. And the legend on the right-hand side shows the occasion that the sampling took place and a colour assigned to each sampling occasion between March and June. And just to take a couple of examples here, the LM data, you can see that the concentrations changed throughout the season. And the same with D10 on the right-hand side, the concentrations changed throughout the season. And just to put these two dots on there to indicate that there's an average concentration there along the during the period. That's a median concentration, or it's another average. And also to point out, and I'll come back to those averages and why they're important, and also to point out is there seems to be a demarcation between concentrations above this dashed line, which is the threshold for a single pesticide, if you remember, 0.1 micrograms per litre. So there seems to be a lot of samples above that dashed line, downstream or in between D3 and D4. So the area between D3 and D4 seems to be where we get a higher preponderance of higher concentrations. Okay, so on this, back to this map with some further data on it. First of all, I'm going to take you down to the legend at the bottom, and the legend shows that green for improved grassland and orange for rough grazing with a little bit of extensive grazing in between, just very major land use or land management classes. And the pie charts show the proportion of rough and improved and some extensive grazing in each one. So that's the proportion. And just to give you an example here, you can see that at D10, upstream of the sample point D10, we get about half improved grassland and half rough grazing. And then upstream of LM at Lochmorn, it's all, more or less all rough grazing, so 100% in that case, and then proportions in between. But if I just add this dashed line again, you can see that between sample point D3 and D4 down here, that there seems to be a greater proportion of improved grassland. So it does seem to show a demarcation point. Remember that downstream of D4 in the previous graph, there seems to be a higher preponderance of high concentrations. And when we looked at those data statistically, or when Phoebe and Rachel looked at those data statistically, we could see that land use controls showed that the more improved grassland in a subcatchment, the higher the average MCPA concentration. And the more rough grazing in a subcatchment, the lower the average MCPA concentration at each of those, across those sample points. So that's quite a finding, and that's published now in a paper, Morton and others, 2020, and you can get access to that through that web link. It's in press at the moment, but it's open access, so that can be downloaded and distributed. Now, I'm going to change the theme here between land use controls and this idea of whether high resolution data can be used for pathways and risk assessment. And just to orientate you again on the River Derg, there's an abstraction point. And at that point, we measured in the river MCPA concentration and river flow, so the flow of the river. When we multiply those two parameters together, we can get MCPA load when the two measurements, concentration and flow, coincide. Now, to understand the scale of an issue, we measure it. That's a really good principle. And we did this measuring during a spraying season. So if I take you to the x-axis on this chart, it starts on the 1st of April and ends at the end of October last year. And so that's 7 months. And on the y-axis, you can see river flow, and this is in cubic meters per second, that's the unit. And these are very high flow rates. So 200 cubic meters per second is over 200 tons per second on these high flows. And on the other y-axis here, we've got MCPA concentration. So the data show that the MCPA concentration is mostly below that bottom dashed line, which is the 0.1 standard for a single pesticide. And up here, look, the dashed line is the 0.5 threshold for all pesticides. So there are some points above the lines, but there's a lot below the 0.1 line. So that looks quite good. But I guess what we questioned was, knowing that MCPA is very mobile, was this weekly sampling sufficient in capturing the full scale of the issue? So if we understand an issue by measuring it, we measure more to understand more. And in this slide, we can see some extra infrastructure at that point on the River Derg, where we measured or collected water every 7 hours during the spraying season, 7 days a week. And on the next charts, that's going to be denoted by a red circle, open circle. And we also concentrated, or Kevin Aitchison, the PhD student at Ulster University, concentrated on some storm events to see specifically what could be sampled between these 7 hours. And they're denoted with a purple dot on the next maps. So refrigerated samples, they were taken away and analysed down in AFBI whenever they needed to be. And the river flow data is public data available from the Rivers, not the Rivers Agency, the Department for Infrastructure now, and it's at their Hydromet Cloud website, which you can access. So there's the weekly data again. And when we add the 7 hourly data to that same data set, you can see that more sample concentrations are above the lines, and there are higher concentrations as well. So it does seem that the 7 hourly samples pick up a lot more than the weekly samples. When we had the 1 hourly data in there, so Kevin managed to capture 13 storm events during that period, the concentrations go up even higher, and they're linked back to these storm events, which are denoted with the very sharp blue lines. That's the river flow going up and down. So higher concentrations, and more frequently above the dashed lines, the threshold lines. Now, if we multiply the 7 hourly data, the red dots, by the 7 hour flow data, then we can turn MCPA concentration, and this is in micrograms per litre of water, that's a concentration, we can turn that into a load. So that will be in a mass per unit time. And that's what we've done on this next chart here, look. So there's MCPA load. That's milligrams per second as measured every 7 hours. Now we can do two things with these data. We can add all that up and look at the total load of MCPA as it's transferred down through the river, and that's a real eye-opener. But we can also study the patterns of these loadographs, let's call them, and the shape of the loadograph to determine pathways. And that's what we did. And that's with Per-Erik Melander at Chagas working with Kevin Aitchison at Ulster University. So if we add all those MCPA loads up across the 7-month period, you can see that it comes in fits and starts. There's a big jump there in load and a more stable period here and so on. Till the end of that 7-month period, we end up with 85 kilograms of MCPA coming down through past that river system, through that river system. Now that's a lot, and in fact, that 85 kilograms of MCPA is equivalent to 7 25-litre containers of the product of MCPA product, going down the river. Now just remember that 2 raindrop-sized drops in an Olympic-sized swimming pool is sufficient to meet the first single pesticide threshold. So this is a lot of MCPA coming down through the river system. Now you can also see, going back to this jump here, that the concentrations sometimes rise or the lows sometimes rise very quickly, and that translates back to a high concentration, much higher than the threshold concentrations. And then there are other periods where it's very stable. And I guess knowing this may help with treatment processes. It might serve as early warning, for instance, if we had the right equipment to actually measure that in real time. Nevertheless, over the whole period, the source water average concentration was about 0.4 micrograms per litre. So that's the concentration that the abstraction works and the water treatment works has to deal with. So that goes into the plant and has to be treated. And just to remind you again that treated drinking water has to have these 2 thresholds. So the treatment process between the source water and the drinking water costs money. It's a burden to the taxpayer. Okay, pathways. When we applied the magic to those loadographs, we determined that overall, and the pathways we determined were more complicated than this, or more complex, but I've just summarized them in 2 major pathways here: surface and near surface all bulked together, and base flow. So surface and near surface pathways accounted for around about 87% of the load of MCPA, with about 13% in the base flow. And what that means is the scale of the issue is that most of it, 87%, is through incidental losses. That's MCPA that's been applied and then lost following a rainfall event prior to it degrading to another product or disappearing altogether in the soil. And the remaining is legacy MCPA, the stuff that just hasn't degraded and it's found its way down into groundwater and is slowly leached down and leaked away into base flows. So that gives us an idea of where the mitigation needs to be prioritized. It's in these near surface areas to avoid that incidental transfer. Okay, so I'm on my last slide now, and I guess I want to finish off by just saying that on 2 sides here, agri-food, the production of food, or food security, however you want to put it, and drinking water are both extremely important to society. If we think of them as being competing interests in the same catchment, well, that's generally regarded in natural resource management as a wicked problem, because we want both things. We really want both things. We want food production, we want drinking water supply. And there are clearly issues on both sides here. Catchment issues, I've summarized these in terms of the research so far, is showing that improved grassland is a major leaking source of MCPA during the spraying season. And that's related back to incidental losses lost in surface pathways. And on the other side, we've got a very high treatment cost, and these are acute high pressure, so they happen very suddenly within a spraying season, coincident with these incidental losses from the land. Now, we can find a way of mitigating these issues, and I guess that can be a subject for another talk as this project goes on. But the middle way, of course, to combine both elements here, or both concerns and both requirements, is integrated catchment management. And integrated catchment management brings together all interests and tries to manage this problem from all perspectives. And it is an example of One Health, a One Health principle, where we consider our needs and the needs of the environment as well. And I know that a future webinar on One Health specifically will be given. Now, the mitigation falls into broad categories of education and training, and also land incentive. And I guess in terms of land incentives, it's whether we can actually move some of these treatment costs, defer some of these treatment costs, and move them back up into the catchment to reduce the problem at the source end rather than the treatment end. So that's what Source to Tap is trying to do. There is an education, training and land incentive scheme in place in the Derg catchment, and we hope to report back on that in the future. And Pat, Mark, that's the end of my talk.
Great, Phil. Thank you very much for that. And thank you for talking us through those graphs in a stepwise fashion, because there was some complicated information that you were presenting. Now you can just, if you could stop sharing your screen there, Phil, and you could turn on your video again for us. Yeah, I was just looking at the graph there that you were showing in relation to the loader graph you talked about, the cumulative detection of MCPA in the catchment. I'm just wondering, that spike around June, is it possible that was linked to low rainfall, and that you're actually getting a higher concentration because the river levels were quite low?
No, Mark, I think you have control of my video at the moment. I can't.
Okay. Yep, I'll switch that back on for you there. Yeah.
Actually, no. For this particular catchment, it's the opposite. It's because we had rainfall and lots of runoff in June, and it was subsequent to a period of application. Now, in other parts of the country where surface runoff is prevalent, we might see that, and in fact, that has been measured in Wexford catchments by the Water Protect project. So where we have less of a surface runoff, then we might see that concentration increased during those dry periods. That's what the data so far is suggesting. But in these northwestern catchments where we get a lot of rain and a lot of runoff, this is a very wet area, then we get that incidental sudden runoff, and that's why the loads are so high.
Oh, in general terms, Phil, what does the results of this project mean for from a policy point of view? I see, look, you have the education measures in place, and we will see the impacts of those. But you didn't mention the regulatory aspect to interventions.
Yeah, and I think that's an even higher level conversation about the use of these pesticides in these sensitive areas anyway, and I think that's a conversation that we should have, but I think it's one for the future. I think we need to know more about it. I think the purpose of my presentation today was just to add that extra dimension of understanding through what the data is showing. So this is data driven. There isn't a single country in the world that's measured MCPA concentration at the resolution we have, and this is an investment through this Interreg funding. And the reason for that is that the analysis is expensive. So we know more by measuring more, and then hopefully we can make more informed decisions based on those data. But it is a conversation to be had down the road on the very high level policy implications. What we'd like to do is reduce that prevalence or that incidence of MCPA through the actions we're taking in those catchments, which is alternative ways of handling, education, training, and other incentives in the first instance.
We just have a question here, Phil, from one of the viewers asking, are there other pesticides than MCPA on the radar for the Source TAP project? Well, are you looking at other?
We do. When we look at MCPA, we look at all acid herbicides. There's a suite of herbicides that are measured at the same time. But they're there in trace. If MCPA is small but above the thresholds, the other ones are well below the thresholds. There's certain occasions where we do get a spiking in other acid herbicides, but MCPA by far is the one that's leaving the land in great quantity.
Mm-hmm. And just a clarification more than anything else, Phil, in relation to your definition of rough grazing and extensive grazing, how did you determine that?
So these are broad land use classes, and I understand there'll be some kind of merging of definitions, but these are from the standard maps that we use to define land use, and I guess there is a bit of a grey area between what is rough and extensive, what is extensive, what is improved, but the difference between rough grazing and improved grazing is quite clear on the ground and also on the maps that we use.
Okay, and is that a land use map that's available in the north?
This is the Corrine maps.
Oh, I see. Yes. So these are satellite imagery. Yeah. Okay. Very good. Okay. Pat, lots of
plenty of questions coming in across the spectrum of the presentation. One from Cecil Alexander. Have we got it wrong in setting the bar too high for the concentration of MCPA in water? Okay,
so I guess the question is related to the tiny amounts. The standard for a single pesticide is 0.1, and I guess these standards are based on extensive research on toxicology, and they always err on the side of caution. And I guess all I can say is I wouldn't be the first in the line to be a guinea pig in trying to set new standards for these. They're there for a specific reason, and it's to protect human health. And when human health is concerned, then there's always a big margin of caution put on those concentrations.
There's a question there in relation to degradation, and how long does it take for degradation to occur of MCPA? And I suppose the corollary of that is under what conditions then, and what's the variability under different conditions?
MCPA degrades in oxygen-rich and in sunlight to a half-life of about 12 to 14 days. So that's on the label. In reality, when we get into anoxic environments or oxygen-poor environments, such as deep soil or sediments, bottom of lakes, and groundwater, then that slows right down. And I guess that's why we're seeing that persistence in the base flows in the rivers, is that that degradation hasn't fully occurred. So we have to again think about degradation rates that are published in terms of laboratory studies that are in ideal kind of laboratory circumstances or plot scale studies. The reality is when we're into our catchments, different soil types, different geologies, different rainfalls, then that degradation can speed up, but it can also really slow down.
The question there asking or commenting maybe that the information about MCPA looks to mirror very much the behavior of phosphorus loss. Yeah,
it does. And I guess what happens with the difference is that the phosphorus can be incidental, but there's a large amount of that transfer is legacy. So it's phosphorus that's built up in the soil and then can become available as well to runoff. Whereas with MCPA, that legacy is reduced because of the degradation of it and because of its roots down into groundwater. So it's mostly incidental. But in terms of the mobility, I mean, it's the reason we chose the transfer continuum approach to do the review, is that there is some parallels there with phosphorus.
A question from the graph you showed at the very beginning in the time series. What was it about 2015 that caused so much problems?
Yeah. That's a good question. We'll have to go back and look at the data. Yeah, I don't know.
Right. Okay.
There's a question here in relation to the time frame for incidental losses. Is there a time frame, or in other words, how long after application before it is considered a legacy and coming from base flow?
Yeah, and that's a good question as well. And I guess it rains a lot, and in the northwest, it's a lot higher than where we are at the moment. So, we get about 900 millimeters here on the north coast, and you get about 900 millimeters per year in Wexford, in the southeast. But over in the Derg, their average rainfall is 1,700 millimeters. So the amount of rain and the frequency of rainfall is high. And so the chances of a rainfall not occurring between application and degradation is diminished. So that's the problem, is that that's an environment where runoff is fast and rainfall is high, and that degradation is not occurring. I guess that rainfall immediately following application is going to be extremely high, but we've got this window of degradation. You know, how many times can we think of where we have 12 to 14 days without rainfall at that time of year? So we do get those spring showers and we get heavy rainfalls in the summer.
So this work is obviously going to have a huge bearing on the types of measures that farmers undertake to reduce the losses of MCPA from the catchments. So, I mean, are there any indications yet as to which mitigation measures have the most impact, or is that too early to say at this stage?
It is too early to say. We have to get a longer data set, and we're hoping to collect those data in the future. And the farmers in this project are working very hard with our farm advisors, and we know that really does work. That one-to-one ASAP type advice network does work, and we've got advisors working with Irish Water and with the Rivers Trust on a one-to-one basis. And we have a series of mitigation measures linked from handling to application, and hopefully that can show us some kind of change in the future as those data come in.
Your presentation stirred a lot of interest, Phil. We've been inundated with questions here, so you can.
Yeah, so I suppose a question there. What sort of MCPA levels are seen in lakes, and how long can there remain a problem in those lakes?
Yeah, I don't have data on lakes to hand. I know we do see, and there are workers with Irish Water have collected those data, and I know that Northern Ireland Water have some of those data as well. Now, with MCPA, the legacies can be related to the MCPA in the sediments. As MCPA reaches sediments before it degrades, it's straight away in an anoxic environment. There's a low oxygen level in lake sediments. And the problem with some lakes is that in the autumn, the lake water turns over. So it's quite a physical process. And that act of turning over can redistribute out that sediment back into the water column. So that's often, that turnover is generally called the autumn turnover. It happens at the end of the summer. And there are some instances, well, it's anecdotal for me, but there are real data out there to show that September and October time can be a time when MCPA is found in lake water, and it possibly linked back to that reason. Clearly, there might be some applications as well at that time of year, but autumn overturn in lakes can bring MCPA back up.
And then there's a lot of inevitability about a lot of questions about mitigation actions. And what are you looking at? I know there was quite a bit of work in the north in relation to mitigation and reducing MCPA usage. What kind of levels of success have they had?
Yeah, so Northern Ireland Water have trialled different mitigation measures in smaller source water catchments and had some success, in fact, at the scale of about 5 square kilometres, and hence the reason for rolling this out, maybe 400 square kilometres. And the types of mitigation used, range from better handling and storage and cleanup operations. That's fundamental. I mean, that's within the remit of all farmers is better handling, cleanup, ensuring that tiny amounts can't get into the nearest ditch or watercourse or be available to run off. But also alternative ways of application might be things like weed wiping, for instance, rather than broad application. Not weed wiping with MCPA, but weed wiping with other products. Now they're still using a pesticide, but it's in a more selective application rather than a selective targeting, if you like. So different products, different application methods. That's some of the main mitigation methods alongside better handling and storage.
And I suppose a question leading on from that, should MCPA only be applied by fully trained professionals and people specialising in it?
Well, I know Teagasc have training, I suppose, operations for MCPA use, and nobody should be using pesticides without proper training anyway.
Mm-hmm. I think you said you had a couple of catchments that you were looking at. Is there consistency between the findings across the catchments that you've looked at, and is it, I suppose, linked with other work maybe as well?
Okay, so we're looking at the Finn catchment at the same time, which is more or less the same, slightly bigger catchment just to the north, and that runs through Ballybofey and joins the Foyle a bit further down. And we're measuring more or less at the same resolution in that catchment, just to see whether that the Derg is not showing its patterns in isolation. And in fact, the Finn is showing exactly the same patterns over the year because they're very close to one another. The hydrology is more or less the same when we look at the hydrology over about 30 years. And the MCPA patterns and loads, the concentration patterns and loads, more or less follow the same pattern. There are some differences. And again, we've clearly we have more than the 7 months of data presented here, and we need to sit down and look at those data in their entirety once the data set's complete.
A question here, do you have any approximation of how much MCPA in total was used in the catchment? So you have a figure for how much was coming out in the water, but I suppose what proportion of what was used?
Yes, I don't have that, and that's a really good question. And those data are always difficult to find. We'll try our best to find them, but it's always a difficult one to find. So no, I don't have that data to hand.
Phil, do you plan to get any better insights into the types of applications or the best type of application method to reduce losses? For example, the weed licker or wiper or spot spraying?
That's good research, and that's research that needs to be done. So if that's not being done at the moment by the projects that I showed in an earlier slide, then clearly that needs to be done. We have research on not just on the application, but how that really, because that translates down into the soil water mobilization process as well. So there might be, different ways of effectiveness. Application methods might have different effectiveness results on what they're to do. But they might also have different results on soil water partitioning as well, and that's research that needs to be done.
Question here, would you expect similar patterns of MCPA loss to water in free draining catchments? No,
and I think we've seen that. There's work published recently through the Water Protect project in Chagask, colleagues down in Wexford, that shows that the patterns in free draining catchments in Wexford are much less than the ones I've reported here. So wherever you're seeing high MCPA in raw water, it's more likely to be in the same kind of catchments where it's a struggle to keep that improved grassland improved, because soil and the rainfall wants to take over. So it's that kind of environment where the problems mostly occur, where the surface is prevalent.
And in relation at a more micro or field level, is there any evidence to suggest that MCPA is being discharged in fields at higher concentrations, or like we talk about critical source areas in a water flow or dynamics perspective?
It's ongoing. It's certainly ongoing. There is room for further research, but some research within Source to Tap is looking at that at the Hillsborough plots by AFBI. So there's a series of hill slope plots where MCPA has been applied, and we're looking at that plot scale in terms of that surface and subsurface runoff. I have no data to show you on that. That's operated by AFBI, but that'll be coming out in the future as well. That's work that's underway.
I suppose a fairly blunt question here. Do you have any idea if the current and hopefully improved practices that have been put in place over the last number of years are still resulting in losses? And if that is the case, should the use of MCPA, should there be consideration of discontinuing its use?
Yeah, watch this space. I guess that's one of the high-level things we're trying to find out in Source to Tap is at the first stage engaging with farming community and trying to find a way of reducing that loss from land to water through better incentivized practices.
Okay, I think we're getting through a lot of questions. Sorry, Mark, have you anything there? I'm just...
Yeah. I suppose it's that general question around the policy interventions. I mean, Ireland we're looking at a renewal of the Common Agricultural Policy, a lot of focus on results-based schemes, and I know that probably extends a little bit beyond your remit here today, but as a, you know, that's the work that you're doing is going to have a huge impact and on policy. I mean, what do you think are the kind of the early messages that we can start to bring from the work you're doing?
Well, I guess on a very high level, you know, we might question why acid herbicides are used in quantity in environments. That's a very high level thing, and that, you know, that's beyond this presentation. But certainly, the data and the results from our project will inform that debate. So, as I said in my last slide, you know, food security, it shouldn't compete with water supply. Those food and water are the two basic things that we have in society, that we need in society. And I guess the data that have been presented here is just on the understanding of that one pesticide that's found in our raw waters. We have to do something about that. Whether we have to build up in kind of degrees, if you like, and working from the farm level upwards to try to reduce those losses. And I kind of incentivization is the best way to do that.
A couple of questions about the non-agricultural use, both domestic and maybe councils, etc., using MCPA. Is that seen as an issue, or is it predominantly agriculture?
Well, it's clear. It's clearly an issue because there is such small amounts can cause the thresholds to be breached. So it is, and everybody owns this problem who uses MCPA. It's just that the number of parks, I suppose, and places where councils apply will be less than the number of places where improved pasture needs to be maintained.
I suppose a question there in relation to the scale of the cost that is being incurred in terms of removal by councils, and I suppose looking at the kind of the equivalence of the potential cost of actually taking it out as a tool for farmers. Is there a balancing act there between the two?
Yeah, I'm not too clear what the question was there, Pat.
I suppose asking the question, the cost associated, if there's a very significant cost associated with removal of it, are we better to look at not having it there in the first place as a preferred option? Okay,
so yeah, that is a good question, and part of source to tap is to specifically look at the economics of that. So is it? I mean, we would suggest that we're better to spend the money in the catchment to reduce the sources than at the treatment plant. And remember, it's not just the treatment plant that's the issue. Drinking water is an issue, but the rest of that 85 kilograms has gone down through the river system. And as I said to you before, we still don't know what the ecotoxicological effects are in terms of issues with other pollutants. So it's in everybody's interest to reduce that pollutant, if you like, coming down the river system. So if there is an economic bonus to actually reducing treatment costs and putting that money back up into the catchment to incentivize reductions, then that's a good thing. That's good for all the actors that deal with freshwater resources.
Question here in terms of degradation products from MCPA. Do they pose any risk, or is it something that has been looked at?
Yeah, they do. Some of the degradation products can have the same toxicological effects as the primary product. I haven't got that information in front of me here, but it doesn't just degrade to nothing in the first instance. It degrades to other products before it finally degrades to nothing. And again, that's in the ideal environment. We've just concentrated on MCPA here because it's found in raw water failures and as an increasing trend. So it's just the MCPA we've concentrated on, not the products.
Okay, Mark, have you anything there?
Yeah, I mean, I think we have captured most of the questions here. Again, there have been a few questions in terms of the impact of MCPA, Phil, on human health, but also on animal health.
Yeah,
can you talk us through that a little bit?
A massive amount of information clearly on all pesticides, and the paper that I showed, the review paper that where I gave the screenshot. Click on the link, and there's a summary, a very digestible summary of all the toxicological effects of MCPA in the human and animal and plant and so on environment. So it's a good read in that regard if you're interested in the toxicology and the ecotoxicology.
Okay. Great.
Just going back to the degradation, and I suppose there's a question there in relation to the time period before rain, because it looks as if we get dry conditions, dry soil, we will get a degree of degradation. Have you any information on the kind of length of time before a potential rainfall event that gets us over that predominantly over that risk of it going into a wet environment and staying there until it's ready to be mobilized?
Short answer is I don't have that information in front of me. And it's something that we can look at in the data to see whether we can, it's because we're dealing with such a patchwork of activity within a catchment, it's difficult to nail down where and when and how much that has been applied at any one time. We just have that general period where MCPA is generally applied in the spring. So cut and then wait and then apply, and then the period to rainfall. But it's something it's a good question. I think it's something we could look at a bit more closely at.
But presumably, I think what you're probably saying is that if there is any threat of rainfall on the way, you shouldn't really be saying don't use it, or if your soil has a very high moisture content in it or a very high water table.
That's exactly right. Yeah.
Okay, on that note, I think we're going to have to draw the session to a close. Time is running out on us. Phil, thank you very much for an excellent presentation. A lot of compliments coming through here on the questions and answers. And what we might do, Phil, is send you a copy of all of the presentation or the questions that have come through here today.
What I would do as well, Mark, is that people can find my email address on the Ulster University website. And if anybody wants to contact me directly with any questions relating to this presentation, I'd be happy to answer if I can.
Very, very kind of you. And that will be on your presentation as well, which will be available for everybody on the Teagasc website. So just click on Teagasc and go to webinars, and you'll find a list of all of the webinars. And just to let you know that next week our webinar is going to be coming from we're going to have Patrick Barrett from the Department of Agriculture. So this is a change to the advertised schedule. So Patrick Barrett is going to be talking to us about creating and shaping the development of Ireland's bioeconomy. This is a theme that is becoming very important in how Ireland's agri-food sector develops. So do join us next Friday for that. Before we go, I just want to say a big thank you to our production team, Andy Boland, Catherine Keena, Pat Murphy and Yvonne Maher, and also to our partners, the National Rural Network, Food Drink Ireland SkillNet, and Dairy Sustainability Ireland for their continued support of the series. So from all
Mark, just one thing, just we said last week that just we would open up our question and answer session just at the end of today and keep it open for people to maybe come to us with suggestions as to what might be useful to include going forward, and suggestions even on how we operate. So anything you have to say to us to give us a little bit of advice to try and improve what we're doing, or maybe meet additional needs, we'd love to hear from you. So we'll leave the question and answer open for the next 10 minutes or so, and we'd love to get some feedback from you. Thanks very much.
Yeah. Thanks, Pat. So from all of us, thank you very much for tuning in. Take care and stay safe. Thank you.